Hi everybody, my name is Mrs. Boyd and I am a high school math teacher at Hume-Fogg Academic Magnet School in Nashville, Tennessee. Today I want to talk to you about the unit circle. Now my focus today is going to be really just on understanding what the unit circle is, figuring out how to get all the coordinates that go all the way around it, and then being able to find some basic trig values from the unit circle. If you have not learned about radians yet, it might be helpful to do that first. So please feel free to check out the lesson that you can find at this website. This explains what a radian is, what all the radians are around a circle, and how to convert them. So for today's lesson, I'm not going to really spend much time talking about why the radians are what they are, because I want to focus on the points around the circle. Feel free to check out this lesson though, if you think that might be helpful. First, let's talk about the unit circle. This is actually one of my favorite things in math, one of my favorite things to teach, one of my favorite things to use. It's really important. It's also simple. The reason it's called a unit circle is because the radius is 1 unit long. 1 unit, that's why it's a unit circle. There's some important things about it. They're helpful to know. If I drop a line going down from that radius, creates a right triangle. And this point right here, points can always be described by a coordinate x comma y. If we were in class right now, I would be trying to get you guys to kind of like figure some of this out on your own. So I'm having to do a little bit of more talking and explaining than I normally would, but hopefully you kind of still get the gist. This space right here on the horizontal part of the triangle is my x value. That's what the x coordinate comes from. And this part is the y value. So there's going to be a few different identities and some things that come from this. And in order to help us with that, we need to do a little throwback to integrated math 2. You guys remember trig? Good old SOHCAHTOA. Trig ratios. Trig ratios work for any right triangle. Right triangles are, they're similar to each other if they have the same angles. So you can kind of blow them up or make them small and their ratios will still be the same. And that's why trig ratios work. So it's kind of cool. Let's start with what we know about sine. Sine of an angle, don't get scared by that symbol. That's just a theta. It's a Greek symbol that's often used for angles. So sine of theta equals opposite over hypotenuse for all right triangles. So for our right triangle, the opposite side is y, and the hypotenuse is 1. So y over 1. But the thing is, anything divided by 1 is itself. So that means that sine of this angle, and I'm actually going to label the angle in our triangle. It's that angle right there. Sine of our angle equals y. Interesting. It's going to be helpful. Let's look at cosine. I'll write it up or underneath here. Cosine of an angle is equal to adjacent over hypotenuse. And our little SOHCAHTOA thing is just to help us remember that. There's nothing magic about it. It's just to help us remember the definitions. So the adjacent side is the one that's like next to the angle, which the one that's next to the angle in this case is x, and the hypotenuse is 1. So actually, cosine equals x. This is only true for the unit circle. So we have to make sure we keep that in mind. So if the point is x comma y, and x equals cosine theta and y equals sine theta, then that means that every point on this unit circle can be described like this. Every xy is actually the same thing as cosine comma sine. This is going to be super, super, super helpful for us later on, especially when we're trying to solve some trig identities. Off to the side here, I want to show a little something about tangent. So you might remember that tangent of theta is opposite over adjacent. And in this case, opposite over adjacent is y over x. But didn't we just say that y is the same thing as sine and x is the same thing as cosine? Yes, we did. So that means that tangent is actually equal to sine over cosine, which is another super helpful identity that we're going to be able to use much later when you take pre-calculus. Okay, so now that we know that, we need to actually figure out what these XY points actually are. The good news is, well, I don't know if this is good news. There's an infinite number of points around a circle, but the good news is you only need to know the key ones, the ones that are kind of like our special triangles. So let's take a look at that. I'm going to draw a new circle. Pretend that that's a circle. And I'm going to go, that doesn't quite look right. I'm going to go like halfway right there. So if you're thinking in degrees, this triangle, I'm going to blow it up a little bit, would be 45 degrees, this angle right here. I know I said I was going to work in radians. I will. I'll get there. I think it's helpful to think about this with degrees at the moment because most people are used to that. Remember that this is a unit circle, so I know that my radius is 1, which means the hypotenuse of this triangle is 1. And because that's 45, and because the one in the corner is 90, that means this upper one also has to be 45. Again, you have to use your imagination a tiny little bit to pretend like I drew that exactly correctly. But if both of those were 45, then both of these sides should be the same thing. Now, some of you guys might remember special right triangles, and if you do, that is great. Special right triangles are super helpful, mostly for doing things quickly, especially on the ACT and the SAT. They love those special right triangles. But in case you forgot, let's talk about how we can actually find these sides. I would probably use the Pythagorean theorem. X squared plus x squared equals 1 squared. Well, x squared plus x squared, there's 2 of them. So that would be 2x squared equals 1. And now if I'm trying to get the x alone, I need to divide by 2 on both sides. And I have x squared equals 1/2. How do we get rid of a square root? I just said the answer. I always do that. How do we get rid of a squared? You take the square root. And so if I take the square root of both sides, I get x equals the square root of 1/2. Let's talk about how to simplify this. In case you forgot, taking the square root of a fraction, you can take the square root of the top and the bottom. So the square root of the top is 1 and the square root of the bottom is square root of 2. That is not very proper. And so what we're going to have to do is simplify this. And I'm going to like scoot this whole thing over a little bit so that I have a little more space to write. We need to rationalize the denominator. Right now, there is an irrational number in the denominator, which is just not proper. So I'm going to multiply by the square root of 2 on the top and the bottom. And I end up with square root of 2. And the reason I can do that, is because that's actually 1. I like to call that a big fat 1. It's a 1, but it's like a fancy 1 because, you know, if you divided it, you give a 1. So you're allowed to do that mathematically. And what's going to happen is you get a square root of 2 on the top, and then on the bottom, I'm going to write in red here, square root of 2 times the square root of 2 is 2, because it's equal to the square root of 4. So what I've just found is that that x value right there is square root of 2 over 2, which means that this x value must be square root of 2 over 2. So I just found my x and my y value. And I think I'm going to circle it or like scoot everything over again to look at my triangle here. So that means that this point right here is square root of 2, square root of 2 over 2, comma, square root of 2 over 2. Because we just found the x value and the y value. Great. We just found one of our key pieces. So now let's look at another one. I mentioned that generally we only have to memorize or frequently use the ones that are key, like the most common ones, special ones. So we just did the 45 one. Another one is one that's like right here. And if I drop a line down, this angle, I'm going to make it 30 degrees. Let's suppose that I drew that just perfectly and it is a 30-degree angle. So remember, this is a unit circle. All right, this one's a little bit trickier if you don't remember your pattern, but we can figure it out together. 30 degrees, 90 degrees, so that means the top has to be 60 degrees. I know that this is 1. I think the best way to figure this out, if you've forgotten, if you remember, maybe I should start with this. If you remember your special right triangles, then you would remember that the short side is always half of the hypotenuse, which would mean this is half. And that the side across from the 60 degrees is always whatever x is times the square root of 3. So in this case, it would be 0.5 times the square root of 3. Okay, which is square root of 3 over 2. But it might be a little stretch thinking that everybody remembered their special right triangles. So what I'm going to do is pretend like nobody remembers what a special right triangle is, and you are having to figure this out. Okay, I went a little too far. Here we go. Here's my way of figuring this out. I'm going to double this triangle, like reflect it over. If I do that, I have another triangle that is familiar to me that is special, and that is an equilateral triangle. So that means that this is also 1. Well, that makes sense since I reflected it. But because this is 60 degrees, 60 degrees, 60 degrees, that means that this side is 1. And so if I wanted to find just this half, hello. If I wanted to find just this half, this would actually be 0.5, or I could say 1/2, that might be better. Okay, so I have my triangle. This is 1, this is a half, and I need to know what this is. So I'm going to go back to my good old Pythagorean theorem and figure it out. If I square 1/2, I actually square the top and the bottom, and so I get 1/4. And I am leaving things in fractions because I think it actually makes it easier for us to simplify. So I'm going to subtract 1/4 from both sides. And then that will give me x squared equals 3/4. And just as we did a little bit ago, if I want to get rid of a squared, then I need to take the square root of both sides. So, and I also just learned that taking the square root of a fraction means I can take the square root of the top and the bottom, which in this case, it's a lot easier than the last one because I don't have to rationalize anything. Square root of 3 stays on the top, but thankfully the square root of 4 is 2. So there's that square root of 3 over 2. So what I just found was that that side right there is square root of 3 over 2. I'm going to go back up to my circle and label that. So what I just found was that the horizontal side was square root of 3 over 2, and that the vertical side was a half. That makes this point, since it's xy, square root of 3 over 2, comma, 1/2. Okay, we're going to keep going. There's one more kind of. It's actually the same one as what we just did, but it's turned. So, sorry, those are not centered very well. If I did a triangle like this, where this was 60 degrees, notice that that's still a 30, 60, 90 triangle. It's just turned up on its side. And so the short side is actually going to be a half, and the tall side is going to be square root of 3 over 2, because it's exactly the same triangle as what I just did. It's just turned. So this point right here is going to be 1/2, comma, square root of 3 over 2. Cool. Let's take all of these and actually put them on a unit circle and see what it looks like. Here's a unit circle. I started labeling the angles kind of close in, and then I eventually started spreading them out. But these are the same angles, but labeled with radians instead of degrees. So pi over 6 is the same thing as 30 degrees. Pi over 4 is 45. Pi over 3 is 60. Pi over 2 is 90, et cetera, et cetera, et cetera. So let's label the points that we just found. Earlier, we determined that this point right here was square root of 3 comma 2, sorry, square root of 3 over 2 comma 1/2. And that the one way up here was essentially the same thing, except it was turned, so it's 1/2 comma square root of 3 over 2. And then before all of that, we found that the middle point was square root of 2 over 2 comma square root of 2 over 2. Okay, I know that memorizing the unit circle might seem daunting, and you don't really need to do it for integrated math 3 at this point, but it's one of the first things that you'll learn in pre-calculus. And if you have this memorized, it will make your life so much easier for multiple units. I promise you, you're going to want to know this circle. But if you only memorize the first quadrant, you should be able to figure out all of the other quadrants. So let's go across. So I'm going to draw a little dotted line across here just so you can see what I'm talking about. If I start with that top point and then move to the left, isn't that the same height as the point was? And it's also the same x distance, but what has changed about it? It used to be a positive half, but now it is negative half because it flipped over. So this is negative half, but the height stays the same. And you'll notice that this actually happens with all of the triangles. You can kind of like go across, or all of the angles. My x is going to be negative, but my y is going to be positive. And now I have the second quadrant labeled. That wasn't that painful, right? Notice that in this corner, everything is positive, comma, positive. I'm in the first quadrant. It's all positive, positive. In the second quadrant, the x is negative, but the y is positive. But what happens in the third quadrant, you might ask? Well, you're pretty smart, so I know that you know x's are negative and y's are negative. So I'm gonna like take the points above and kind of like look down and see which points they match up with. So notice, I'm gonna draw an arrow for a second, but you see I'm gonna start with that one way up there and then go down. So if I do that, that means that this point right here is negative half, because the x is still negative, and negative square root of 3 over 2. And then if I do the same thing from there to there, so again, I'm just doing reflections. I'm just like following down, seeing what's going on. This one is negative square root of 2 over 2. Sorry, that's a little sloppy. Negative square root of 2. Oh, I can't handle that. I'm gonna have to clean it. Okay. So negative square root of 2 over 2, and then also negative square root of 2 over 2 for the y. And then for the last point, it comes from that one. Notice, just gonna go straight down. My x's stay the same number, my y stays the same number, but it's reflected, so it's negative. So I'm gonna have negative square root of 3 over 2, negative half. All that's left for quadrants is the fourth quadrant. So going this way, you can either look top to bottom or left to right. Either way, they're gonna line up. I've been doing the pi over 3's first, so I'm gonna go from here to here. And this is gonna be positive half, because this time the x's are positive, but my y's are negative because they're down. Negative square root of 3 over 2. This one's going to be positive square root of 2 over 2, negative square root of 2 over 2. And then this one is going to be positive square root of 3 over 2, negative 1/2. Okay, so I started to get excited, but then I realized we're missing 4 points. Don't you see those 4 points? The thing is, these are probably the easiest ones. What is the radius of a unit circle? 1. 1 is the radius of a unit circle. So we need to use that. If my radius is 1, here and here and here, notice I'm writing those ones, that means that the radius is also 1 here and here. So I can actually find this point right there that I just circled. My x value is how long my radius was, which is 1, but I did not go up or down, so my y is 0. For this one, the 90-degree one, or the pi over 2, my up and down is 1, but I didn't go left or right. So my x oops, I just wrote that backwards. My x is 0. There we go. My x is 0, and my y is 1 because I went up 1, but I didn't go left or right. And all of these have a radius of 1, which means that the pi side, or the 180, is also 1, but it's going to the left, so that means it has to be negative. So I have negative 1, 0. And then 3 pi over 2 is the same thing as 270 degrees, and it's going down 1, but it did not go left and right. So I have 0, comma, negative 1. So I have the whole unit circle filled out. This is great news. This is so helpful. And the thing is, I'm not going to go much further with this, but I did want to say something that's exciting. And it goes back to what we talked about in the beginning. Do you remember how we said that all of the points are the same thing as cosine, comma, sine? I know you remember that, right? That means that now that I have this, I can actually find the cosine and the sine of any of these angles, these key angles. So for example, if you had a question that said, what is the sine of pi over 3? Well, you know that sine is the same thing as y, and so you would go up here to pi over 3 and look, sorry, it's overlapping, but you would look and see up in the corner, the sine of pi over 3 is, whoops, square root of 3 over 2. And that's just the answer to the question. Sorry, I gotta choose the right thing. Square root of 3 over 2. And I could say, what is the cosine of 5 pi over 4? And you would look, 5 pi over 4 is down in the corner in blue. Cosine is x. So the answer is negative square root of 2 over 2. This could go on and on and on and on. There's so many questions you could be asked. You can actually have negative angles by going down instead of up, or like instead of counterclockwise, going clockwise. But that's for another day. So I'm hoping that today's lesson showed you how to fill out the whole unit circle. And I'm also really, really hopeful that, there we go, I'm gonna bring it in here. I'm really, really hopeful that if you understand where the points on the unit circle came from, that you'll have an easier time remembering them. Memorizing them is very, very helpful for figuring out questions quickly. But if you forget something you memorized, it's really easy to mix things up and then get the total wrong answer. If you understand where it comes from, which hopefully this video helped you see where it comes from, then hopefully it'll stick a little bit better. You'll be able to figure it out if you need to, and you can be successful with the unit circle in pre-calculus and in calculus. So I hope this was helpful, and I hope you guys have a good day.